Hi everyone, it's Carol and Jake again, and today we're going to be solving Advent Day of Code 19, which, as you can see, features elves. I've got my elf hat on, and they are doing a white elephant. I don't have any white elephants. I have a blue elephant, and Jake thinks I'm ridiculous.
Knows. Jake knows you're ridiculous.
Yeah. All right, let's share my screen and get started here. So Jake, why don't you tell us about the problem?
Okay. So reading through the problem text, basically the idea is there's going to be a bunch of elves sitting in a circle. And if you're unfamiliar with white elephant, basically
it doesn't matter if you're familiar because they're doing it wrong anyway.
Well, yeah, it's true. What they're going to do here is you get to steal presents from the other people at the party. In this case, the rules are you just always steal from the person to your left that has presents, the first person to your left that has presents. So they got their example here. You got 5 elves. So the idea is that elf 1 steals from elf 2, and then once you have no presents, you're basically ignored. So then elf 1 steals from elf 2 is ignored, elf 3 steals from 4, then 4 is ignored, and then 5 takes all of elf 1's presents. So now elf 1 has nothing and they're ignored, and then 3 steals all of the presents, all the rest of the presents from 5, and then they're the winner. And that's what we're trying to do, is which elf gets all the presents. And what's really tricky about this one to me is...
But you said scary. You said you're scared of this one.
Yeah. I mean, they're kind of the same thing in my mind. Like, I'm scared of this one because I have a feeling that it's trickier than it seems. Because it feels like that's fairly straightforward. I can think of a couple like pseudocode ways of solving it. But then like I see that the puzzle input is there are 3 million elves, which is a lot of elves. But I feel like the trick's going to be the naive solution is going to be too slow. But one thing that I think is kind of fun about Rust is, like, we saw this in I think the last problem, where we're like, this is going to be slow, we're going to have to run it in release mode and blah, blah, blah. And then it just kind of was actually fast enough because it's Rust. So like you kind of get some speed for free, but not always. There's still like algorithmic, you do it wrong, you do it wrong. So yeah. So anyway.
Do Carol and Jake know things? Let's find out.
So do you have an idea, a solution structure?
I mean, I'm kind of thinking we have a vec of numbers and we take them out of the vec if they don't have presence anymore. But that's like I tend to go to the mutatey procedural kind of solution first, whereas I think you tend to go with more functional kind of filtery sorts of things, but I'm not sure that that will work here, or I can't wrap my head around doing something that direction. And then I wonder, is mutating the vec going to be too slow?
Mm-hmm.
So I don't know.
Yeah. Which kind of mutate of the vec are you thinking? Are you thinking actually removing elements from it, or?
I was, yeah.
Because like that's.
But we also have to keep track of our spot.
Right. So if you remove them, then you need to like put the elf ID in.
And there's also the wraparoundness. Like, do we want to use like a ring buffer or something that goes around?
Mm-hmm.
Or do we just not care about that?
So I feel like the naivest solution I can think of is we have just a giant array of...
You mean vector?
Yes, giant vector of numbers. And the numbers are how many presents the elf at that position has.
Okay, so we don't take anyone out.
We don't take it out, we just set it to 0. And then we scan to the next 0. So it's going to be very...
Scan the next non-zero.
Or yeah, next non-zero. And then like set that to 0 and move and add that number to the current one. Yeah.
Okay, so there's the other bet going on here, which is, do we care to keep track of how many presents each elf has at any particular point, which part 2 could potentially use somehow, but we have no idea.
Or just have a true false.
Yeah.
This has presence. That's a good point. And especially the fact that there are 3 million gives us a nice upper bound, because there's only 3 million presents total.
Yeah, unless part 2 is, how about 6 million elves?
Oh, sure. Yep. So I'd be willing to start it with a U64, which is a lot of presents, but
so you're saying we're going to store the number of presents each elf has?
I think we should.
Okay. All right.
I think it'll help with debugging too.
Okay. Then let's take that route and see how far we get. So should we start with the sample with 5 elves?
Yeah.
Or is there something smaller that we could do? Should we do just 2 elves?
Sure. Yeah. And then basically just we have elf. Also, we're going to do 0-base indexing because we're programmers, but we'll just add 1. Like elf at index 0 is elf 1. So we just have to make sure that we translate that when we do the real problem.
So we're going to start with
Yep. I like this because I see that you're going to be writing. Okay, you're not going to do what I thought. I thought you were going to actually write the problem in line and then we'd extract a function, but I don't mind. We know we're going to extract a function, so.
I mean, I wasn't going to solve it in the test.
That's fine.
Why would I solve it in the test?
It's fun sometimes. It's very TDD.
No, it's not. You have to make it fail first.
That's true.
So I kind of want
Okay.
Is that what you would expect?
And just to be clear, so you have 1, which is elf number 1.
Yeah. So like the opposed
to index 0.
Right.
Okay.
Because that's what we have to put in the box.
Yep.
Because this one expects elf 3
Yeah.
to be the answer, which is elf number 3, not elf at
Yep.
index 2. So
Okay.
I want our outside public method
to take care of that.
Yeah.
All right.
I guess we could call this puzzle.
Yeah.
Because that's my function that I'm already calling in my main. Okay. So how do you feel about this?
I think it's a good start. Circle doesn't need to be mutable though.
Yeah, I guess. And like circle, is that like this is there's a lot of meaning in here that isn't being conveyed, but
we'll see how that plays out.
Okay.
Sometimes it's nice to have not much fancy going on.
Oops.
I was wondering because you had your pre-made.
Yeah. So we really want to just say we have 2 elves because the knowledge of every elf starting with one present, like that's part of the problem.
Yep.
Okay. So now this should nice and fail. Okay. So get a number of elves. And this is actually going to be like a U size because we're going to make a vec that long, right?
Yeah.
And then this is also kind of going to be a U size because it's going to be an index +1. So it's going to be convenient to have this as a U size.
Yeah.
Okay, so this circle is going to be mutable.
Yes. Vec bang 1 semicolon input.
Yeah.
Because we're going to want that many presents.
Yeah. Okay.
All right.
Now what?
Now we draw the rest of the owl.
Yeah.
So, I mean, we have
So we
our simple
start-
test. Yeah.
Well, we want like
Okay.
um
So now we want to find the next elf with presence.
after this index.
Mhm.
Okay, so can we literally use the scan method? I forget what the scan method does.
No, the scan is an iterator method. It does other things.
But vec.iter.
Scan is a way of creating new iterators. I think you just want
Find filter.
just go to the iterator page.
No, I want to go to the vector page.
Okay. I don't know what you can do here.
Look, sometimes there
It's true.
are methods on vec that are useful.
I see a useful method. It's called iter.
like contains. Okay, fine. Where did you go, iter? I saw you. No, I can't find you now. Okay.
This is like the most roundabout way of getting.
This isn't even the page we want, is it?
I mean, it has.
Oh, okay. All right.
It has them, but
You want the next page.
I mean, this is fine. So
Skip while, take while, skip, take.
just where's find? I'm pretty
What?
sure find returns a number.
So just for an element of an iterator that satisfies the predicate.
Okay, so it does not. It returns the item. It might be called index instead of find
Position?
or position. Yes, the next one.
Okay. There isn't like a find mute that returns like a mutable reference to the item.
It depends what you're iterating on. So if we do iter mute,
Mm.
but
I'm thinking of like the entry API.
mhm. I guess that's a good point because we do want to do this. The problem is that you're going to want to mutate two parts of the vector at once.
Oh, right.
So-
okay. All right. Position is what we decided we wanted.
Yeah.
So position.
Circle iter position.
But we want to start.
Right. So
Yeah. How do we do that?
you just make a slice of the vector.
So
Yeah.
we're
So-
gonna have to handle wraparound in a second, but
Yes.
this test case is good because we don't have to wrap around for this.
Right. And that will be like our next test will be one
Yeah.
that requires wraparound. Okay. So we've got our circle starting after the current elf.
So this is going to return this off, and that returns an option.
Which is again going to be there's two things there because like when we actually run out, that's when we end our looping. So that's one thing.
Mhm.
But it's also when we want to wrap around, we'll get a none. So we have to handle both those cases.
Okay. So I want to call this presence.
Okay.
Or like num. Because this is the index. So we want to do two things. We want to set circle at current elf equals plus equals circle at I.
Yep.
And then we want to set circle I equals 0.
Yep.
And then the none we're going to leave unimplemented for now.
Yeah.
Okay.
So this isn't going to work at all, but I would go ahead and return 0 and just see what the compiler complains about at this second, just because I'm kind of curious. That's okay. So
what
we're matching it to reference, so we need to, yeah. Okay, so it does compile and it fails, which is good. Okay, so we've found elf, the next elf. So I should have, or the sum branch should have been run once, and I is going to be the index 1, we believe. So we've moved that. Yeah.
we can see. I like seeing things. Okay. Debug 01. Ooh, that's
Not at all what you thought we did.
no. What did I do?
Aww.
I expected 2-0.
We should print out what I is inside the sum because, oh, I know what happened. Position is within the iterator.
Oh.
So we need to increment I by current elf plus 1.
Let's extract that into a variable. This is next elf. This is like relative next elf, and this is absolute next elf.
Yeah.
Oops, that's, I just want the index.
Yeah.
So now we have 2-0. So we do have to handle this now because we need to handle the case when there's only one.
Right. And we gotta
we have to know when to end.
Yeah, and we have to like construct our loop of some kind.
Yeah.
So so we know that so we've got absolute next elf, right? And we know that that elf is not valid. So we could search for the next non-zero elf after that. And that's essentially where we would continue.
I feel like this isn't what you're saying, but what I want to do is try this, but instead of taking the slice from current elf plus 1 to the end, I want to take the slice 0 to the current elf.
Why do you want to do that?
Because that's the wraparound.
Okay, so you want to like hard code it for our current 2. Because if we had 3, we would go to the next. We would need to go to index 2.
But this is finding the first one that isn't 0 anywhere from here
After-
to the end of the
After
array,
the current elf.
after the current elf.
Right.
So if we get none,
Yes, I'm sorry. I was thinking of the wrong none case. I'm thinking of, actually it's in the sum, like we have to like figure out what next is. We're thinking of different parts of the loop. So we
Yeah,
can keep doing what you're doing.
that's why I said I don't think we're talking about the same thing.
Okay.
But because so here now we need to factor this out, but we want the same match, but we know more stuff now. Because if we do this match again in here on the same thing, if here we found some, then we can do this again.
So we don't need to do the absolute because we're starting from the beginning of the array.
Okay, right. So we don't need the +1 because that was because.
Did you mean to put I there?
Yes, I did.
Okay.
So if we found none here, then we have a winner.
Which should be current elf.
Right.
Okay. +1.
It still doesn't handle the looping.
Right, but I see what you're doing now. Okay.
But so once, if we make it into this sum case, then then we should loop.
Right. So the easiest thing we can do is, at the end of the match, we basically do that same logic again, start at current elf, find the next non-zero position, and that's
So the reason I'm putting this in here
Mhm.
is, well, so this is the same thing. Like we need to do this wraparound again. But like we should definitely get something here, because if we didn't get anything, we should have already returned.
Right.
And I'm sure I'm missing some edge case where it won't actually have done this. Yeah, I hate this code.
Okay. Do you want to try our? Do you want?
But do we want to make it work first and then make it better?
We can at least get past that first test and then comms it out and try a different approach. Right. So I think that what you have.
But we're still not looping.
Yeah, you basically just want to throw a giant loop around. Yeah.
Around like everything.
Yep. And that return is our breakout of the loop.
Hopefully.
This might actually pass the test. No.
No.
Go back to the.
It's not wrong.
So you're.
See, I'm not doing the looping, and we definitely need to loop in here. But why is it?
Do you mean the wraparound?
Yeah.
Okay.
Yeah.
So you're starting at current elf, looking on. And yes, because we're not doing the wraparound.
2.
Well, so that's like a optimization. It can be 1 because we just set it to 0.
It's going to be 0. Okay.
The problem is that we're not doing the wraparound here.
Yeah.
So instead of that first, or like right before that dot expect, do unwrap or else. No, what do we want? And then, because we want to take that option and we want to then chain it with, or you could do a match. Match might match with the other bits, but basically we need to start at the 0, or like from the beginning, dot dot current elf, iter position blah. Like what you have in your none case, your first none case, we need to do that here.
This can I?
You can.
Because we only care about that case. The other case, we don't want to touch it.
Okay.
Right?
I mean,
if this succeeds,
yeah.
We don't want to do this. And you were saying maybe we should do a match to mirror these, but we only care about the one case.
I mean, you can't write this code because circle blah 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 is going to be an option, and you can't assign an option to an integer type.
Oh, okay.
So you might as well just do.
Right.
So if we found that, then we'll do the panic.
Okay. How does this look? I mean, horrible, but do you think it'll work?
It's horrible. I agree.
Yeah, I forgot something.
Yeah, I was going to have you get rid of your braces, but whatever.
Yeah, that would match this one better, but we're gonna get rid of all of this anyway.
Okay.
Oh.
Same thing in
there. All that work, and we're still going horribly wrong. Okay, I can't think about this anymore. What?
Abandon ship.
Yeah.
Okay.
Yeah.
Let's just go ahead and comment it all out or move it somewhere at the bottom of the file, just because it's a lot of typing. Works. I'm pretty sure we're not going to come back. All right. Now we can delete this, which is the best part. So what about the other idea we had, where we actually have an array and we remove from it? What issues do we see with that?
So the thing that I would want to be in that array is the elf number.
Yep.
So I think there's a way to make a vector with numbers, like having 1 and 2 in the spec. We'd still need like a current elf index to know where we were in the circle. I don't know. I can't. Let's try it. I feel like it's like a range or
what
to I want this to be vec 1, 2, but I don't want to write that out. I don't want to hard code this. I want to call something based on input and get a vector.
Do you also want to keep a track of number of presents?
I wasn't going to, no, because we're just going to take them out.
Okay. So then I think you're looking for 1 dot input plus 1.
Right.
You'll need parentheses, of course, but
collect.
Yeah.
And then make this
I actually had meant the parentheses around the input plus 1, but you
Oh.
need the ones that you put as well. Okay, so now we have a vector of ELF numbers.
Mm-hmm. So,
So we're going to start at 0.
actually, like we could start at 1 because 1's going to be the first one that we remove. We'll see if this works. We're going to take that out of the current index,
Mm-hmm.
and then no, I hate this.
Why?
Because now I want to advance, but you don't need to advance because it's just
You do need to advance.
right. But like now, the thing at 1 is the next thing that I should remove.
No.
No, but I just removed it.
Because now it's the ELF after that turn. What you're saying, everyone would always get removed, and only the first person would ever go.
So we have let's do the
okay.
5 case.
Yep.
So the first time through, we remove the ELF at index 1.
Yep.
Then next.
Then the next ELF gets to go.
Okay.
So we increment the index.
But that's okay. It's weird because this is like next ELF to go.
Okay. I'm going to change indexing. Yeah.
Can't wait for refactoring tools. Tell you what. I know Emacs.
Emacs can do it, but evidently can't be recorded by YouTube. So, 6 to 1.
Trade-offs.
Okay.
Okay. So.
And then our wraparound is next ELF to go mod equals the length.
Or just greater than the length, right?
I mean, sure. Add all those extra conditionals in there if you want.
Okay.
And put all that in a while loop. While circle len greater than 1. And then circle dot pop. Nope. Oh yeah.
Yeah, pop returns an option.
Yeah, somehow in my head I was like, and then of course it'll know that there's.
I did the up arrow and committed again.
That's good.
Yay, it passes.
Of course it passes.
Okay, let's
do the next test.
The next test.
Okay, so for the next test, there are 3 elves. So the first one goes, takes presence from 2.
I was just going to skip to 5.
Oh, all right.
I don't know what happens with 3 elves.
Okay.
5 elves works.
And let's put the real number in then. That
chug.
You're gonna want release on that, yeah.
Also chug.
I did a little bit of thinking. I used a calculator, and 3 million 64-bit integers is only like, if I did the math right, it's only 24 megs. Can you click over the memory tab? Just see if I'm right-ish about that. Yeah, it's not anywhere near the top, so. Okay. So while this is running, we can spend time thinking that we could have spent thinking before we wrote code. something about this algorithm seems very it seems like we should be able to basically write a number or like a small calculation. So like pop back to the code while this is running. Okay, so like we remove like all the odd ones or something like that. Like I feel like there's a pattern to which ones we remove, and therefore I kind of feel like we should be able to write a single thing that is order 1 that just returns the answer.
Okay. How confident are you in this?
Confident that it exists, fairly. Confident that I would actually be able to figure out what it is, not the biggest.
Okay, so let's talk about,
I would just let, okay.
No, it's not satisfying. And it's eating up my resources. It could be affecting the stream. Okay, let's talk through the 5 case again. I can type.
Right.
All right, so we start by removing 2 and 4.
Yeah.
Right? So if we say we do that, then it's going to be the last one's turn. Right? And I want to do this with an even number of things next.
Yeah.
So if it's this elf's turn, then we're going to start removing from the odd ones.
Yeah.
Which leaves us with 3, which is the answer.
Yeah.
Okay, so let's do this with 6. So if there's 6, we still remove the evens because 1 takes 2s, 3 take 4s, 5 takes 6s, and then it's 1's turn again, which means we remove the evens, whereas
the even positions.
The even positions.
Okay.
Which is different than, like, I want to be able to write rules.
Yeah. Well, I mean, we could have just 2 rules perhaps.
Yeah.
Which is it odd or is it even?
Okay, so this is even, and we're saying if the length is even. See, I feel like the first one, it might be a special case too.
The first
round. I'm not sure.
Okay.
Like, I feel like we need bigger. I don't know. No, let me finish working this one out. So if we move 2, we move 4, 5 takes its turn, we move 6, then it's 1's turn.
Mm-hmm.
So 1 takes 3s, and then it's 5's turn, and 5 takes 1s. Right?
Mm-hmm.
So okay, this one is even length. Let's horrible pseudocode. This is not okay. Length is even, which means remove even positions.
Yeah.
And this is length is odd. Which also means remove.
Yeah, keep going.
And then length is even. Like,
don't worry, just keep going.
But it's not working. This is remove odd positions.
I think the difference is, so when we did on the first row, when we did length is even, the next one to go is at the beginning of the row. So on your line 15, we started at the beginning.
Right.
So it's not is it odd, it's is it odd and are we starting at the beginning? This is my hypothesis. Because with this one, when we were done, we were still about to start at the end. We had to start at 5. No.
But
you don't start at the end on the very first.
But then the next one isn't 0. This is start. Okay, I guess it is. We need to do the other one again, though. This one is start at the end. This one, we removed 3 here, and then it's 5's turn, right?
Yeah.
Okay, so this is len is odd and start 0. And what we're going to do is remove even positions.
Mm-hmm.
Actually, these aren't positions. Not in 0 indexed.
Yeah, I figured I wasn't going to argue about that.
Okay. So that gives us 1, 3, 5 again, but this time,
right.
And the start is the end. And in this case, we remove odd positions. Which leaves us with 3. I feel like we're missing some cases. Because we have even and starting at the end. Starting at the beginning. Okay, we have even start at 0, even starting at the end, odd starting at 0. Okay, I guess.
Those are the 4 cases of the things we've identified.
Right.
Whether or not we did the right thing is different.
Yeah.
The other thing here is that because I want to say that there's even some way that we can tell. I don't know. We should try this and see if we pass our test.
So our guess is that with this algorithm, when we're doing it with 3 million elves, like each remove is triggering a potential. It's moving memory around, right?
It should be, yes.
And what we're doing here is we're going to like remove half of the array every time instead of going 1 element at a time.
Yes. And
so we're hoping it'll be way faster.
That'd be the idea.
Okay. So okay. We start with our circle and our starting index. And we're going to match on circle length and start.
Yeah.
And our options are going to be, I want to do the 2 starting at 0 first, because then we don't have to care
good point.
about the other ones. And are we gonna have to? We should do
Did you want to Do you want to do the equals 0 or do you want to do 0 and 1? You should do equals 0 there. So you have true and false.
Okay, okay. All right. So
true is even.
I have true, false, true, false. Those are 4 cases.
Yeah.
Oops. Ooh. Oh. I was just trying to align my operators, and I forget the keyboard shortcut for that. That's embarrassing. Okay. So I'm gonna switch these because we do want to do 0-based. That's Jake moving around the couch. No one's farting.
What?
It sounded like a fart from over here. I just don't know what it's gonna sound like on the video.
I'm over here trying to like chat.
Okay. So true means even. So if we're even and starting at 0, then like, I don't know. Okay. Yeah, I don't know what I'm doing. This is still going to do like a reallocation.
Yeah, that's fine.
Okay.
And this is the second tricky part that I don't quite know how to do. Because, oh no, actually, never mind. Keep going. Yeah. Circle that it or dot, never mind.
Do I need to put something in here? I can just put it in here.
Yeah.
And I forget which comes first.
Yeah, I absolutely never remember.
Oops, no.
I want to say the indexes first. Yeah.
I is the index and then the val. Okay. Index, val. Actually, we don't care about the val here.
Right.
And is this a tuple?
It's 2 arguments.
It's not a reference to a tuple?
No, it is a tuple. You're right.
And so what did we say here? Removes the odd positions and filter keeps things. So we want to keep the even ones.
Okay.
Can I just throw the collect on the end because we're going to have to collect all of them? Is that going to be sad?
It'll probably complain because the types of all the filters will be different. It's fine.
Oh, and we...
Right. You have to map back.
Yeah, we don't want the indices still in here. Okay, how's this?
So you're going to iterate, you're going to enumerate, we're going to filter, we're going to map back to the value, and then we're going to collect. Seems like a good start.
Okay. So then for odd and at the start, we also want to do the same thing, or did I mess this up?
Odd. So you removed 3, which is at index 1.
Mm-hmm.
So
Okay, so this is actually that, I think. This feels weird. Okay, so even and start at the end is we want to remove the even ones. So I'm going to copy this and just change this to not equal. And then odd at the end is also
remove the same ones we just did.
no, wait, odd and even end is evens. Okay.
Yeah.
Okay. This feels weird. This can't be right.
I mean, it is right, I think. The part that you're about to hit, I think, is where we want the other piece of information.
What?
We don't know where to start on the next iteration.
Mm,
And that is the other piece. That's where, if it's what the length is, comes into play, I believe.
okay.
So if we started with something that was length that was even, then I think on the next turn, we're going to, no, I might be wrong there. We might be deleting the same things, but when you delete the even amount of an odd one, and when you delete an odd amount of an odd one,
Right.
that's what changes your, so it's, were we odd and are we now odd again?
Well, you're always odd.
Yes.
So how do we tell that?
Well, if what I just said was true, we're collecting, we have a vector of the old size, we have circle len, and we can, instead of overwriting circle to start with, we can create a second one. And then we can say, if the old length was even and the new length was even, the old length was odd, we can do those mappings.
So this is really going to be like true or false.
Yeah.
We don't actually care about the end. We just need to know. Why are we even?
You left it. You just haven't removed it yet.
So we don't actually care about this?
Not for creating the next circle.
Okay, but we do care about this.
Later, yeah. That's what we were just saying, that's what goes into.
I'm lost. Okay. So you're saying we get the original length.
Yeah.
And then we get next circle. Call this instead of circle 2 because that was just a horrible name. And then we get that length. And then if something started at 0 is something else, it's something else. And you understand what goes in here and what
Not necessarily. I just,
Can we reason this out again?
okay.
So here,
So when you start with an even amount, there are 6 things in that array.
okay,
So the length is even. And we're starting at the beginning. We're going to end up on, like, if we start with an even amount, we remove an even amount, or remove any, if we start with an even amount, always going to,
and with an odd amount.
no. Because if we had 8, you remove 4, you'd still end up with even.
Okay.
It's more
But-
like if we started, so here, we started at 0. We started at the beginning.
I think you need to highlight it for people on the stream to see what we're
Okay.
talking about.
So if we start at the beginning,
Right.
and if we start at the beginning, we had an even amount, then
Start at the beginning, and we have an even amount.
So like if we look at our vec here, so we're going to start at the beginning, so we start at 1. Then we remove 2, remove 4, remove 6,
Mm-hmm.
and the next time, we're going to start at the beginning.
Right. So what?
So start at 0 is true in that case.
Yeah.
So
So
right
start at 0 is true.
which is
Okay.
fine because it didn't change, but whatever. Okay. Our next case here is we started at the beginning. And it was odd length. Okay. Then, in this case, we also need to know if we removed an odd or even amount. Because, or in this case, because we know how many are, so like if we remove an odd amount, if we remove, like, so well here, let's stop that, okay. So we start at the beginning, so we're gonna remove 3.
Mm-hmm.
And then it is going to be 5's turn.
Mm-hmm.
So we know that we are going to start at the end.
Like, how do we know that?
We know that in this case, because we removed the odd ones. Like, I don't know how we're gonna do it, just say and removed odd. Removed an odd amount.
So, like, we can determine that with original length minus next length.
Is odd, yeah.
That's removed an odd amount.
Okay.
I want this to be a match statement because I feel like we're missing cases, and then we can just let the compiler tell us. But I'm not sure what to match on exactly.
I want you to have variable names as opposed to those giant amounts of math, but
Okay, all right. We'll start with variable names. We already have start at 0. And that's just a Boolean, so you should be fine with that. But I mean, we can extract these into variable names if you want. I don't know what you want.
well,
Like this is, I still don't understand what we're doing, so I'm doing mechanical things right now. So if we started at 0 and we started with an even length.
so I mean, I'd much rather you understand it than type the code, because if you don't understand it, then when I miss something, you're not going to catch
Yeah.
it.
what I'm like, the first one makes sense to me.
Mhm.
I'm not sure why it's
Okay. So like that
that
last
part.
clause?
Yeah.
Okay. So on your line 36 here, we have vec with 3 things in it.
Right, which is an odd length.
It's an odd length. Then down here on line 41, we have the same thing, the exact same vector,
Hmm.
but we're starting at the end.
But isn't that based on the value of this, not the value of this? Like, isn't this clause always true if this is true?
I don't know.
Like, why don't you know? Because that's the only difference between these two cases is with this one we started at 0,
Mhm.
and with this one we started at the end.
Okay.
So like the next case is we did not start at 0, which is we start at the end and the length is odd, which is this case. Then I'm lost again. I just lost myself.
So in this case, we remove the even 0-based position, so we remove 1 and 5, right? Which means we will start at the beginning of the next time. So start at 0 is true.
Okay. Okay.
Now, this is where the matches might actually come into play.
Yeah.
Because I'm pretty sure that if we were to like simplify this logic, we're done. Like I think that's it.
I think doing this is better though. And then no. Like the last case is else, which is not starting at 0 and started even length. And where do we have this case?
The thing is, I don't know that it can happen.
Okay. Let's see if you're right. Well, so now we just need to throw a big loop around this, right?
Yeah.
Wait, where's our end case? Instead of loop, we can do a while.
Yeah, we want like the same pop. Wow. And after that giant set of if else's, we need to assign circle to next circle.
Okay.
Yeah, what's the compiler got to say to that? What's right there?
It's not a.
On the map, it's not a reference.
Oh.
And the circle dot iter, I'll go ahead and make that into iter. That way it just saves us from having to dereference later.
What?
You're collecting.
Yeah.
But we didn't tell it they were collecting into a vec.
Oh. Why are we not using this? Oh, yeah. You thought it had something to do with
Yes.
what was left, but then we
you
decided it
yeah.
wasn't.
a test pass, which is scary.
Mm-hmm.
Okay. You want to run it and release and see if it also takes forever still? Nice. You should print out what, well, that could be a very large thing. So my follow-up to not thinking that it can happen is that if it's, the problem, so we believe this to be the case of we're starting at 0, we're not starting, we're starting at the end, but we have an even length. Yeah. That'd be good to, you've got Ridgeland.
Yeah, okay.
Okay, so probably not what we want to print out. So I guess if we had an odd number of things,
See, I
and
thought
we
we
removed
had
an odd number, we can end up at an even. So that's
Yeah.
why I was,
I thought we had all the cases in these two examples.
so start at end, and it is even. So okay, that's this vec15 on line 43 here. So we want to remove the even zero-based positions.
That doesn't, it's not even right. Because then we end up with 5, right? And I've messed this up.
So 1, 3, 5, and we remove 3. So that means it's now 5's turn. So yes, the length is even, and we're supposed to start at the end. That means it's 5's turn, so we remove 1. So we're removing index
Is 0.
0, index 2, index
Okay.
whatever.
Okay. And
Then
that means we've started at the end.
I would have said start at the beginning.
But it's 5's turn, and
See,
5 steals 1.
See, we need more because the problem is we need to know what position is 5 in on the next.
Why? Why do we need to know that?
That's how all of these are working. Because like, if we go back to the first vector here, so we start at 1, it's 1's turn, we remove 2.
Mm-hmm.
Then when it's 3's turn, we remove 4.
Yeah.
It's 5's turn, we remove 6. That means on the next row, we start at the beginning. So now we are on 1's turn, we remove 3. It's now 5's turn. On the next row, we start at 5, which means we remove 1. And then on the next, and we also remove more. And on the next row, do we start at the beginning or the end? The problem is on this example, we only have 1 left at this point.
So you're saying instead of, in order to know what start at 0 should we set at for the next go round, we need to know next circle length.
Not necessarily. So this vec15, and we're starting at the end, just make up a new vector that is 4 values. Okay, and we know that we are starting at the end somehow.
Okay.
Like that's the state that we printed from the panic, right?
Right.
So we've got an even length, and we're starting at the end.
Start at 0, so it's false.
Okay. So now it's 4's turn.
Mm-hmm.
So now we're going to remove 1 and remove 3.
So we've removed the even even zero-based positions.
Okay, which is good because that matches what our text below said. Now we have 2 and 4 are left.
So it's 4's turn, remove 1. 2's turn, remove 3. Then it's 4's turn.
Yep. So
start at 0
is false.
But you're saying I can't just do this.
I'm saying that based on our previous information, you didn't know that. You said
Okay.
that that's what you wanted. So I agree that you were right.
Okay, all right. Let's just check our tests, even though we don't have that. Okay, it ran a decent amount of time. We have an answer. Let's go check. I'm not feeling super confident right now, though.
What's the worst that could happen?
It says, oh, we're right. Okay, all right. Okay.
All right, now describe all the logic in the commit message, please.
Oh, geez.
You know it's going to be exciting.
The part 2.
Oh, yeah.
I'm so scared.
Yeah. The nice thing is it can't possibly be how many presents they have, because that's just the input number.
Oh.
Ah, good. Yes, the folly.
Oh, no. Oh, this is going to be a pain in the butt.
If 2 elves are across the circle.
Oh, this hurts my head already. So if we're elf 1 and looking over 3 and 4, 3 is on the left. Okay. The rest of the elves move in. It's 2's turn. So they still have 5. And then they don't move in. Or yeah, there's 3. 4's turn. Chooses elf 1. And it's elf 2, elf 4. Okay. Okay, yeah, I don't know what to do now. Like, can we? I feel like now we can't do the removing half trick.
Probably not the exact one, but I feel like there's going to be something similar.
Okay, I want to see it in this format.
I would, yeah.
So we start with 5 elves. And 3 gets removed. Then it's elf 2's turn, and 5 gets removed. Why did I do that? That's like 5 gets removed. And 4 means 1 gets removed. And then elf 2 steals from elf 4, so 4 gets removed. I'm not really seeing a pattern here.
Mm-hmm.
Do you?
No.
Okay, we're screwed.
Should we wrap up this video so that?
Yeah, I think I need to think about this for a while so that people aren't staring at this. Tune in next time for us maybe figuring out how to solve this. Thanks for watching. Bye.